Hey guys, today we are going to have a look at longest common subsequence problem. So, given two strings, find the length of longest common subsequence in two, right? For example, if we are given these two strings, then the length of longest common subsequence is 4 and following is the subsequence. Now, first we are going to implement a naive recursive solution for this, right? So what is the naive way to solve this particular problem? What we are going to do is we are going to take each character from the string 1 and say that this is the start of the common subsequence, and we start looking for the characters in the second string, and once we have found the character we are going to find remaining characters from string 1 into string 2. Okay, so for example, if we take a, right, then we find a here, right, and then we take g and then we try to find g after a. Similarly, once string 1 is completely exhausted, then we start with g, saying that g could be possibly the start of longest common subsequence, and then we start from the beginning. Okay, so that is the basic idea of how to solve this particular problem. Let's see how we can implement it. We are going to implement a recursive version, so the solution may look a little bit different, but idea remains pretty much the same. Now let's implement it. I already have set up my main method in order to test our functionality. Okay, so LCS is the name of our function. Okay, so LCS now if our last characters matched, okay, then we are going to make a recursive call this way. One, basically because the characters have matched, it means that there is at least one character that has matched, right? So that is why. So whatever new matching characters would be below these indices, we are just going to add one to those. Okay, otherwise we subdivide the problem. Okay, and and we need maximum of it. Okay, here. So as you can see that what we did is basically we decremented size of one of the strings. What we are saying is that okay, a and g didn't match, just subdivide it into two different problems, which will say that a may not be, first one is that a may not be the start of the common subsequence, so remove a and start with g, and second says that g may not be start of the matching subsequence, so start at a, start at x, right? So in the next iteration a and x would be compared. As you can see that we have done pretty much the same thing that we have been talking about, that is take one character as a start of the common subsequence and just try to find that in the second string, and then if it is found then proceed with the rest of the characters in one string and proceed in the index where the match was found, right? So that is the fundamental over here. Okay, even with the subdivision we are doing pretty much the same thing that we were discussing. And for the boundary condition, if any of these are 0, we cannot proceed, right? We cannot go any further. We cannot compare anything anymore, right? So so this is it, right? Let's see if it works fine. So cool, our implementation is working fine. Okay, cool. Now let's try to implement a recursive dynamic programming solution for this. Okay, we are going to use our previous implementation in order to implement a recursive solution. Okay, of course we are going to need auxiliary array, which is actually going to save previously calculated values, and we are going to require two-dimensional array because we have to we are actually taking care of two indices at any given point of time. Okay, now as we have our auxiliary array, what we want to do is basically first we want to save the values. Okay, so how we are going to do that? Here when we have calculated a value, we are going to save it in m and n index. Okay, and same thing we have to do for non-matching condition. Okay, so now we have saved the value, right? At this point of time we want to return a value as well, so we are going to return this. Now how we are going to use it? In order to use it, all we need to do is check if we have already calculated this value. And how we are going to do that? We are going to just check if this value is not equal to -1. If it is not, then we are going to return that value. So so this is pretty much it. Actually, this is all we needed to do to have a dynamic programming solution. Now let's see if it works fine. Let me initialize an auxiliary array pretty quickly. Okay, now note here that we are actually referencing mth and nth character, so we have to have array size which is +1 in both the dimensions. Okay, now let's just pass auxiliary array here. One more thing we need to do, we are going to call our DP implementation, right? So we have to pass auxiliary array to all of them, otherwise it is going to call our naive recursive solution. Okay, so yeah, this is it. Let's test if it is working fine. There you go. So our recursive dynamic programming solution is working fine. Okay, now let's see how we can actually implement iterative version of our solution. Okay, so we are going to use this as our reference. Okay, now let's rename our function. We don't need these returns. We need 2 for loops. Okay, Now inside this we are going to need these conditions. The only thing that changes over here is the indices. So idea here is that we are taking value from the higher indexes, and the reason for that is our indices are going from high value towards the low value. So we cannot save our results in the lower values because they will be updated, right? So we are going to save our values at the higher indices, right? Similarly, for the second case, we are going to take values from higher indices, and the only thing that changes over here is this. Okay, that's our implementation. Now what we want to do is we want to return 0th element. Okay, so this is about it. Actually, this is all we wanted to do. Okay, in the function call, however, we want to change one thing. This was -1 previously, as you might remember, right? So we have assigned 0 to it now, because now we are not actually checking anything as we did here, right? We needed -1 so that we knew that value has been actually populated, but in this particular case we don't need it. Okay, so let's just see that if our solution works fine. Okay, so apparently there's something wrong here. Here. So that's about it. Cool. So our implementation is working fine. So that is how you implement longest common subsequence problem in 3 different ways. Basically, as I have mentioned in my previous videos, that if you can come up with the naive recursive solution, then it's pretty straightforward to implement a dynamic programming version of it. Okay, that's it for this video. If you need the code, I have given a GitHub link in the description section. You can get it from there. And yeah, that's it. Thanks for watching.